Okay, we are live. If there is anybody in the chat section, please let me know if I am properly audible and visible to you. Just give me a quick thumbs up in the chat section if everything is fine with my stream. Okay, so everything is fine with my stream. Let's just wait for 1 or 2 minutes so that more students will gather and then we'll start the session. Unsupervised learning clustering algorithm, in which we are going to discuss mainly about hierarchical clustering, and we are going to solve questions that how to attempt questions based on hierarchical clustering. Okay. Okay, so I hope everything is fine with my stream and we can start our today's session. So we have discussed about unsupervised learning, that in supervised learning we have labeled data, and in unsupervised learning we have unlabeled data, right? We do not have any output for the input features. Now what is it? Then I have to like I have to train my machine so that they can work on unlabeled data as well. So that's why we are going to work on clustering algorithm. So what clustering algorithm does? So clustering algorithm basically divides the data set, unlabeled data set, into number of clusters. That means a particular cluster, or I can say that a particular group has similar kind of properties, and if I'll talk about another group, it has another kind of properties, right? So that's what we have. So that means unsupervised learning clustering algorithm used to identify inherent patterns, groupings, or structure in data without the need for labeled output, right? So that means within a particular cluster we have same kind of properties. That is by clustering algorithm. Right now we have discussed the first algorithm in clustering algorithm is k-means. Right, we have seen that how to form a cluster using k-means. What we have done, we have taken, let's suppose we have some points, we have some points in my data set. Let's say uh, let's say this is my data set points, right? So what would I do? I'll take 2 points as a cluster. Step one would be I'll take any 2 points. Let's suppose if I want to form two clusters, the important thing is that I need to know that how many clusters I need to form. Let's suppose I need to form two clusters. So what would I do? I'll take randomly any 2 points as my centroid, right? And then I'll find out all the points, all the data points distance with these 2 points. And let's suppose I have taken v1 as first point and v2 as first second point. So I'll find out the distance of all those data points with these v1 and v2. Then what I'll do, i'll uh, I'll find out that whichever, like I have all the data points, then I'll see that let's suppose this data point has a minimum distance with v1 as compared to v2. That means this data point has distance less than distance with v1 is less than distance with v2. So that means this point goes to cluster 1, right? v1 comprises cluster 1 c1 and v2 comprises cluster c2. So let's suppose if I'm saying this point a, so a points go to cluster 1. Similarly, if I'll see this b point, right, I'll find out the distance with this v1, and let's suppose v1 is this point and v2 is this point, right? I have taken. So that means what I have to do, we have to assign all the data points a particular cluster. And how do I assign the cluster for all the data points? I'll find out the distance of all the data points with the centroid, and with which centroid the data points have minimum distance goes to that particular cluster, right? If any data point has a minimum distance with v1 as compared to v2, then that data point goes to cluster 1, otherwise it goes to cluster 2, right? That is the process. But now what would I do? Next process is I have to iteratively work on this process. I have to find out new centroid, and that I can find out taking k-means. That means I'll take average of all the values in this cluster 1, and that would be my new centroid, and then I'll repeat the process again, right? So that's how I work on k-means, right? But the next algorithm we have here is that is hierarchical clustering, right? That is again important, and there is a question in GATE data science exam based on hierarchical clustering, right? Hierarchical clustering is a method of cluster analysis which seeks to build a hierarchy of clusters in a given data set. So let's suppose I have given 6 points, 1, 2, 3, 4, 5, 6. So what would I do in, I'll take these 6 points as different clusters, right? I'll take these 6 points as 6 clusters at the start, right? So what would I do? Then I'll find out distance of one with every cluster, distance of two with every cluster, like this. And let's suppose 1 and 2 and I have minimum distance. So this would be my, this would considered as my one cluster, right? I'll consider this as one cluster, that is 1, 2, right? This is my one cluster. Then I'll find out, I have 4 clusters, 1, 2, 3, 4, 5, 6. Sorry, I have how many cluster? I have 5 cluster. One cluster is 1, 2, another cluster is 3, 4, 5, 6. So I have 5 clusters. Then I'll again join these clusters. Let's suppose 1, 2 and 3 has minimum distance. Then I'll join these clusters. Let's suppose then 4, 5, 5, 6. Like I'll form the clusters like this. We'll see that how I'm going to form that, right? So if I'll see here, so the decision whether regarding whether two clusters are to be merged or not is to be taken on the basis of measure of dissimilarity between two clusters. So let's suppose I have points, let's suppose I have points A, B, C, D. So how I am going to take these points, because at the start I have taken all these 4 points are different clusters, right? So how do I merge any 2 points in a particular cluster, right? What I have done, let's suppose I have taken A and B have minimum distance. So this is my one cluster. So I got here 3 clusters, A, B, C and D, right? I have 3 clusters here. So, and there may be a possibility that next distance is, this is small. So now I'll get A, B, C. This is one cluster and another cluster is D, right? So I have 2 clusters here. So that I'm merging these clusters, right? You can see here that I'm merging this A comma B into one cluster on the basis of dissimilarity, right? So that means here similarity I have taken as a distance into consideration. So if there is another similarity given to you, then I can use that. So measure of dissimilarity I am using to merge any two clusters, right? Now the distance between two cluster is usually taken as measure of dissimilarity, right? Distance between two cluster is taken as measure of dissimilarity. A dendrogram is a tree diagram used to illustrate the arrangement of the cluster produced only produced by hierarchical clustering. So what I'm telling you, this A, B, C, right? I'm merging these one by one by according to the distance. Let's suppose first I'm merging AB, then I'm merging ABC, right? So this would become as dendrogram, right? We'll see that in detail now. So there are two types of hierarchical clustering: agglomerative clustering and divisive. So we'll see one by one that what is agglomerative and what is divisive. So let's suppose we have this data set. It has 6 points. So that means first of all, in agglomerative clustering, I'll take 1, 2, 3, 4, 5 and 6. I'll take these 6 points as 6 different clusters. So does anybody tell me, does anybody know what is agglomerative clustering? Anyone, guys? So what is agglomerative clustering? So basically what I have to do, see, you can see directly that 1 and 2 has the minimum distance. So that means first cluster gets merged as 1, 2, right? So this is my first cluster, right? So now at this step I have 5 cluster, but I have 5 cluster, 1, 2, 3, 4, 5, 6. Then I have seen that 3, 4 has the minimum distance. So I'll merge these cluster. So that means I'll get 3, 4 and so that means at this point I have 4 cluster, 1, 2, 3, 4, 5, 6. 1, 2, one cluster, 3, 4, second cluster, 5, another cluster, and then 6. Then you can see that if you would find out the distance, 3, 4, 5 are together, are forming the cluster. So we'll join 3, 4, 5. So we have this another cluster. And then you can see the distance between 1, 2, 3, 4, 5 is less than as compared to 6. So I'll merge these cluster. So I'll get here 1, 2, 3, 4, 5, right? And at the end I'll join to get one cluster, that is this one, 1, 2, 3, 4, 5 and 6. So you can see that this is what, this is my dendrogram. This is my dendrogram. And let's suppose I need one cluster. So I need one cluster, so at the top I got one cluster. And let's suppose I need two cluster, so I'll divide it here. So you can see that here I have two cluster, 1 2 3 4 5, and another one is 6, right? So two clusters. So if I'll divide it here, now I have three cluster. What is the three cluster? So you can see that here we have, on this line we have 1 2, then 3 4 5, and then 6. So that means we have three clusters. And if I'll divide it here, so we have 1 2 3 4 5 and 6. That means we have four cluster. If I'll divide it by here, so 1 2 3 4 5 6, that means we have five cluster, otherwise we have six clusters. So you can see that we can get any number of clusters using agglomerative clustering, right? So according to our needs, so you can see that this problem gets really easy at this point, because we have to find out a distance and then just start combining the points, start combining the elements or data points, right? So that's how we'll get a cluster. And according to our need, that okay, we'll work on a data set and then we'll see that how many clusters we need, right? So we can find out using this division, right? So that is agglomerative clustering, right? So we are start from bottom and then we'll move to top, right? So first we'll take all the clusters and then we'll start dividing, right? That is my agglomerative clustering. So just let me know if anybody have any confusion that what is agglomerative clustering. Anybody have any confusion in agglomerative clustering, guys? Just let me know. Okay, so next thing we have here is next is we have divisive clustering. Now in divisive clustering, look, like in agglomerative clustering, what we have done, we have started with all the data points as a single cluster, right? One is making itself a cluster, two is making itself a cluster. In divisive clustering, I'll start with all the data points. So that means I'll start with the 1 2 3 4 5 6. I'll start with a single cluster, right? And then starts dividing according to the measure of dissimilarity. So if I'll start dividing, then I can divide this into let's say 1 2 3 4 5, and then we have 6, right? So we'll divide like that. It is divisive clustering. That means we'll start from the top and then go to the bottom, right? Then I'll okay, let's just draw it little bit more like dendrogram. Right now it is dendrogram. Right now I'll divide this 1 2 3 4 5. So how do I divide? According to the distance, 1 2 and then 3 4 5, right? Then I'll divide this 3 4 5 into 3 4 and 5, right? And then I'll divide this 3 4 into 3 into 4, and this 1 2, this is 1, and this is 2, and then we have 6. So you can see that we are getting single clusters as well. So we have to do the same thing. We have to start with, let's say this is 6, just drawing it like a dendrogram. This is 5, right? So this is a dendrogram. So you can see that previously what I have done, I have started from the bottom and goes to the top. In divisive clustering, we'll start from the top and go to the bottom. So just let me know if there is any confusion that what is divisive and what is uh, agglomerative clustering. Guys, once you know, okay, so this is simple because I am drawing it using the figure. Using the diagram, I am drawing this clusters. But do you guys get it? Let's suppose I can find out the distance between 1 to 2. What is the distance between a point? Let's take one example. Let's take one example of agglomerative clustering. Uh, so let's suppose we have some points 1 2 1 2, and we have another point that is 2 2, and we have another point is 3 3, and then we have another point is 1 3, right? So these are the points I have. If I'll find out the distance between 1 1 and 1 2 and 2 2, the distance between, so let's write down these points: 1 2 2 2 and 3 3 and 1 3, 1 2 2 2 3 3 and 1 3, right? So if I'll see distance between 1 2 and 1 2, that would be 0. 1 2 and 2 2, that would be 1, right? 1 2 and 3 3, that means I'm using Euclidean distance, right? I hope all of you know what is Euclidean distance. If x1 comma y1 and x2 comma y2, if I have these 2 points, then the distance is x2 minus x1 square plus y2 minus y1 square, right? So this is a distance, Euclidean distance, so I'm using that. So we have different types of distances, we are going to discuss that as well. So 1 2, distance with 1 2 is 0, and distance of 1 2 with 2 2 is 1, and distance of 1 2 is with 3 3, that would give me 3 minus 1 square, that is, let's say, square root of 5. And 1 2 with 1 3, 0, that would be 1. 2 2 with 1 2, that would gives you 1, square root 5 and 1, right? That would be 0 0 0. So I have to find out distance with 2 2 and 3 3, that would be square root 2. And distance of 2 2 with 1 3, distance of 2 2 with 1 3, okay, 2 2 with 1 3, 2 minus 1, 3 minus 2, square root of 2 again, okay. And right, 3 3 with 2 2, that would be square root 2, square root 2. And then 3 3 with 3 3 with 1 3, what is the distance? 2, right? So now I have to find out the minimum distance. Can anybody tell me that, let's say this is point A, this is point B, this is point C, this is point D. So I have the points A B C D, which points I'll join first? Can anybody tell me? Can anybody tell me that which points I'll join first? 1 2 with 2 2, like I have to see the minimum distance. I'll not consider 0, because 0 is itself a point. Distance of A with A, obviously 0, right? So I have to find out distance of, that is minimum. So I can see that 1 is a minimum distance, I can see. But you can see that I'm getting 2 1 here, right? This one or this one. So I can combine either A with B or A with D, same thing. So let's say if I'm combining A with B, right? So I'll get this value. I'm combining A comma B, A and B here, right? Then what I have to do now, guys, just understand what I have to do. I have to find out distance of this CD. That means now I have the points A comma B. It has one cluster, then C cluster, and then D cluster. So now distance with C and D is fine. But how do I find out distance of A comma B with C? How do I find out that? Okay, just a minute. Yeah. How I'm going to find out the distance? Does anyone know? Guys, anyone? That I have 2 points here with C, right? I know that if I have to find out distance of A with B, I can find out using Euclidean distance. But here we have 2 points and then we have 1 point. So how to find out distance with that? So that's why we have some measure of dissimilarities. So let's understand that, and let's remember how we are going to attempt this problem, because right now we haven't solved it properly. Right, first of all, measures of dissimilarity. I told you that we can say distances as Euclidean distance, squared Euclidean distance, right? In squared Euclidean distance, what I have done, I have just taken a square, right? Previously I was writing xn minus yn square summation, right? Or I can say that what I'm writing, let's suppose we have one point x1 x2 xn, this is first point, and second point is y1 y2 yn, because points can be n dimensional. So the distance would be square root of summation xi minus yi square. That is a distance of that is Euclidean distance. But if I'll talk about squared Euclidean distance, just remove the square root. That means we'll take a square. That is my squared Euclidean distance. If I'll talk about Manhattan distance, I just remove this square and take a modulus here. Modulus of summation xi minus yi. That is my Manhattan distance. And if I have to take maximum distance, so what would I do? So I'll find out this difference of x1 y1, x2 y2, x n yn, and then I'll take maximum of that. That is my maximum distance, right? So these 4 types of distances, just remember, if they give by name, then you can easily attempt it, right? So these are my measures of dissimilarity. But the question remains as it is, that let's suppose I have a comma b in one cluster and in another cluster we have c. So how do I find out distance of one cluster to another cluster, right? I know that if I have 4 points like this, a b c d, right, I can find out distance of a with b using any of these distance, whatever given in the question. If nothing is given in the question, I can use Euclidean distance, right? That is yeah, that I can use. But let's suppose I formed one cluster, a comma b. I got one cluster. Now what I'll do, how I am going to find out distance of a comma b with c, distance of one cluster with another cluster, how I am going to form? So that is a question. Okay, I'll tell this later, but before that, we have these measures of dissimilarity. So it says that measure of distance between group of data points, right? What I have done, I have grouped 2 points a comma b, and I have to find out distance of this group with this c. How I'm going to find out? So this is dxy, distance between x and y, say Euclidean distance, and then I can find out dA comma b, that means distance between group a and b, right? So basically, let's suppose we have one group a in which we have some points, let's say a b c d, we have these points, and another group we have b in which we have, let's say, x y z w. Now to find out distance between these two groups, I'll denote dA comma b. It says that means I'm finding distance with the group a with group b, right? That is a notation. And if I'm writing these points dA comma x, that means distance of this point a with point x, right? I hope you understand these notations, right? So we have used two notations here. That means dA comma b, capital A I have used for clusters, right? This is a cluster, this is b cluster. If I'm writing dAb, that means I'm writing distance between these two groups. If I'm writing distance of small letters, that means the points a comma x, a comma y, all these things. So what I have here is, see, so we have different types of distances defined. So first distance is dA comma b, and that is maximum of dxy. X belongs to a and y belongs to b. So what does it mean? X belongs to a and y belongs to b. uh what I mean, let's suppose I told you that we have a b in this and we have, let's say, c in this. I have two groups. So what would I do? I'll find out distance of a comma c, right? Distance of this a with c and distance of with b with the c. Whichever is maximum, I'll denote it as DAB, D capital A comma B, right? And this is called as complete linkage clustering, right? If I'll use this similarity in agglomerative clustering, this is called as complete linkage clustering, right? So that means what you would do if you have two clusters. Let's say you have, like you can see here that I have given two clusters a b, and in this b cluster we have dce. So I'll find out a with d, a with e, a with c, b with d, b with e, b with c, these distances, and whichever distance is maximum, I'll write down that is my dab, right? And that is called as complete linkage clustering. So let's solve one question, so we'll understand what is complete linkage clustering, and then we'll discuss different methods, right? I have only discussed one, the method, that is complete linkage clustering, right? Complete linkage clustering, that is, in if in agglomerative clustering I'll use this distance, then that is complete linkage clustering, right? And we have another is, if I'll take minimum of these distances, right? Previously I have taken maximum. If I'll take minimum, then this method is called as single linkage clustering. You would get confused, but first let's solve problem, then it would be easy for you. So we have given the data set a b c d e and the following distance matrix. Construct a dendrogram by complete linkage hierarchical clustering using the agglomerative method, right? So using agglomerative method, I have to find out dendrogram, and we have given complete linkage hierarchical clustering. Okay, so first of all, I'll write down the points here. So we have the points a b c. So that means instead of that I'm writing, that means first I have cluster a comma b comma c comma d comma e. That means I have 5 clusters a b c d. Then I'll see the distance matrix they have given. See, whichever Ma'am, D denotes dissimilarity. Ha, right. D denotes dissimilarity. Right. Basically, here I am taking distance in complete linkage. That is maximum distance I am taking. Right. So these are the 5 points I have: A, B, C, D, E. Right. Now I have to first see that we have given the distance matrix. Distance matrix means distance of A with A is 0, distance of A with B is 9, distance of A with C is 3, distance of A with D is 6, and distance of A with E is 11. Right. So now see that whatever value is minimum, I can see that this 2 value is minimum here. Do I have any another value which is less than 2? No. So that means you can see that the distance between C and E is minimum. So now I got my second cluster, that is A, B, and then I have, or I am just writing this as, instead of writing in this format, I am writing here I have one cluster A, B, right, C, D, and E. I'll form a dendrogram at the end. Right, so I have this uh, distance with C and E is minimum, so I'll combine them: A distance with B distance, and then I'll combine C comma E, and then I'll write down D. Right, this is what I have. Now what I have to do, I have to, okay, why it gets closed again? Right, so what I have to do now, I have to combine. Right, I have to combine. So how do I combine? Let's write down here. So I am writing here A, B, C comma E, because now I have to look for the minimum distance: A, B, C comma E, and D. Now I have to again form a distance matrix. So distance with A is 0, distance of A with B is 9. Can anybody tell me what is the distance of A with CE? I want distance of A with C comma E. Right, and using, I have to use complete linkage hierarchical clustering. So that means what I'll do, I'll find out distance of A with C and distance of A with E. Right, so this point I'll find out this point distance with C and this point distance with E. Whichever is maximum, that would considered as this distance. So distance of A comma C, what is distance of A comma C? That is 3, and distance of A comma E is 11. So that means this distance is 11. Does everyone gets it that why this distance is 11? Just let me know if anybody have this confusion that why this distance is 11. And right, next we have same thing, distance of A with D is 6, then distance of B with A, that is 9, and distance of B with B is 0. Now I have to find out distance of B with CE. Guys, anyone have any question between the distance of A and C? If not, then I have to find out distance of B with C. Distance of B with C. So for that I'll find out distance of B with C and distance of B with E. What is the distance of B with C? Distance of B with C is 7 and distance of B with E is 10. So that means whatever is maximum goes to this distance. So that is 10. So we have this distance 10. And distance of B with D is 5. Right? And distance of C with A, I already find out 11, 6, 10, 5. Now I have to find out distance of C with C, that would be 0, obviously, same cluster. I have to find out distance of C with D. Right, next thing I have to find out, guys, if anybody is facing any confusion, just let me know. Distance of C comma E with D. Just tell me by yourself that what is the distance with C comma E, distance of C comma E with D. Guys, let me know the distance. Just solve it by yourself. Let me know the distance, guys. So for this distance, what would I do? I'll find out distance of C comma D and distance of C comma E. What is the distance of C comma D? Distance of C comma D is 9 and distance of C comma E is 2. Sorry, sorry. Distance of C comma D and distance of E comma D. Right, now it is correct. What is distance of E comma D? 8. right? So whatever is maximum, that means 9 is maximum, so I'll write down here 9, right? So this would be 9 and this is 0. Can you tell me which distance is minimum now? Because I have to combine that whichever is minimum. Here I can see that this 5 is minimum, so that means B and D get combined. B and D gets combined here, so that means next cluster would become next combination. Next step would be, I got another cluster, that is I'll combine A as it is, and then I'll combine BD, and then I'll combine C comma E, right? This is as it is, right? So I'll got one more cluster. So do anybody have any confusion? Let me know, guys. Now next thing we have here is that I have to find out distance between these three, right? And whatever is minimum, I'll combine them. So see, whenever I'm finding out distance between two clusters, I have to take a maximum. But whenever I have to combine the points or combine the cluster, then I have to take the minimum distance, right? I hope this is clear. So now next step would be, I'll write down the points. Here this is point A, and this is another cluster, that is BD, and this is another cluster, that is CE, A and BD, and then we have CE. So distance of A with A is 0. Just tell me, guys, what is the distance of A with BD? Distance of A with BD, distance of point one cluster with another cluster, that is distance of A with BD. So that means what I have to find out here, I have to find out distance of A with B comma D. Right? I have to find out distance between two clusters. So for that, I'll find out distance of A comma B and distance of A comma D. What is distance of A comma B? That is 9. And distance of A comma D, that is 6. So whatever is maximum, that is 9. So I'll write down here 9. Right? Right, Varaprasad. 9 is correct. Now tell me distance of A with CE. Tell me distance of A with C. What I'll do, instead of this, I'll write down. Right, I have to find out distance of A with C. So that means I have to find out distance of AC and distance of A. What is distance of A comma C? That is 3, and distance of A comma E, that is 11. Right? So we have the maximum distance, that is 11. So I'll write down here 11. I hope this thing is clear. So this would become 9 and this would become 11. Now next thing is distance of BD with BD is 0. Right? Only thing I have to find out, that is distance of BD comma CE. Guys, this thing you have to tell me, that what is the distance of BD comma CE. Distance of two clusters B comma D comma C comma E. Just find out this distance. Let me know, guys, what would be this distance. Right. That would be 6. This would be 6. So you are telling me 6 for this. Let me check. Are we getting 6? Let me see. So that means I have to find out distance of B comma C here. Distance of B comma E. That means this point, B point distance with C and E, and distance of D point with C and E again. Distance of D point with C and distance of D point with E. That is C. Right? So what is distance of B with C? That is 7. Distance of B with E is 10. Distance of D with C is 5. And distance of D with E is 8. So we got the distance 10. So I'll write down here 10. Prasad, we are getting 10 as the distance. Okay. Okay, no issues. So 10 would be the distance. So now again, I'll see that whatever is minimum, what is minimum? This 9 distance is minimum. So what would I do? I got again another cluster. Now I can combine the cluster. So you can see that which cluster I can combine. I can combine A with BD, right? So that means I got here, that means A comma B comma D. This is another cluster, and then we have C comma E. Now I can write down last and final cluster, that is A, B, C, D, E, because I'll combine remaining two cluster. So that's how we got the cluster. Now I can draw a dendrogram. So how do I get a dendrogram? Let's start with here A, B, and because C and E gets combined, so I am writing D here. Right? See guys, I am writing D here. Right? So that would be easy for me to draw. So here I'll combine C with E, and here I'll combine B with D. Then I'll combine A with BD, and then I'll finally combine these. So this is my dendrogram. So let's suppose I need two clusters. I need two cluster. Somebody asked me if somebody asks me one cluster, I'll see at the top. If somebody asks me two cluster, I'll divide it here. So one cluster I'll get here, one cluster I'll get here. If I need three clusters, I'll divide it by here. If I need four clusters, and if anybody wants five clusters, then I can look at the bottom. Right? So I hope this thing is clear, that how to work on complete linkage hierarchical clustering. Let me know if anybody have any confusion. And guys, before like moving forward, just like the session, let me know if there is any question in this, in complete linkage hierarchical clustering. Right? So that's how we are going to get a dendrogram. Right? So this is my final dendrogram. Let me remove these lines, otherwise you would ask that, would you draw these lines? No, you do not need to draw. I'm just telling you that whenever you require number of clusters, you can divide your dendrogram. Is there any question, guys? Anyone? Any confusion? Okay, so this we have used complete linkage hierarchical clustering. So I have another question for you. This is the question. Same method. Thank you. Okay, so we have same question. Now you have to work on single linkage hierarchical clustering. Single linkage hierarchical clustering. Right? What we have to do for single linkage? We have to look for the minimum distance. Previously, in complete linkage, when I'm finding out distance between two clusters, I'm taking maximum distance, and here you have to take the minimum distance. Is there anything like testing? No, we do not have anything like testing. Because why we do not have anything like testing? Because you can see that we have unlabeled data. We do not know that the, like, if you recommend, if you form a recommendation system, so let's suppose somebody click on a news, so you would form a cluster, so that that cluster would suggest that cluster will suggest to another person, right? So for that, we'll form the clusters, like one for news, one for entertainment, one for let's say weather, temperature, all those things. So that's why we do not have any testing here, because we do not have any labeled data. Okay, so single linkage hierarchical clustering. So guys, just take a distance of d a comma b, and let's say x comma y are the points dx comma y, such that x belongs to a and y belongs to b. You have to take the minimum distance here. So just try this by yourself, right? Try this thing by yourself, and we are going to discuss further, like we are going to discuss about average linkage clustering as well in the next video. And I'll, if anybody face confusion in this, then we'll discuss that as well, right? So we get one method left. So I told you two methods today: complete linkage, and this is single linkage. You have to solve this by yourself, right? If we'll discuss it in the next class as well, right? Single linkage, and then we'll discuss average linkage clustering as well. So yeah, that's all. That's all for today. We are going to continue in the next video. Is there any question? Just let me know. Let me know if there is any question at all. Otherwise, we are going to discuss average linkage in the next video, next lecture. Okay, so yeah, that's all from my side, guys. Thank you for joining.